All right, so let's see if we can get started today. So over the weekend, you were supposed to have completed and turned in lab 2, lab 1, assignment 1. I've done quiz 1, quiz 0, which I am going to do my best to get graded this week and back to you. Because timely feedback is a good thing. So that being said, we're going to move into the next thing. If you had any major problems with any of the assignments that were due this weekend and need more help, please send me an email or send me during office hours. Be happy to go over anything with you that you missed. We are going to move at a pretty decent clip for the next couple of weeks, trying to get stuff done. We will have an exam coming up next week. The way I do exams is I'm going to open it up on Monday, and you will have until Friday to complete it. You can complete it at home. You can complete it in one of the computer labs. You can complete it in the hallway between classes. I don't care. It is completely online. You will have, I want to say it's about 70 minutes or so, or whatever the length of the class period is. So you have a little more than an hour, but you will be on your own merit and conscious not to cheat. But you get one attempt at it. Once you've taken it, you're done. There's no second attempt. If you forget to take it during that week, there's no second attempt. It will turn on and it will turn off. If you run over the time limit, it will stop you where you're at and it will not allow you to finish the test. So pace yourself. You should have plenty of time. There should be plenty of time to finish the test. If you sit down to take it, I will tell you, if you think that, oh, well, so let me take it at home, I can Google search every answer. If you try to do that, you'll run out of time. You need to be prepared. The test is over the reading and the slide decks. So everything that's on the exam will be from the reading and slide decks. It opens on the 29th and it's open that entire week. Sound cool? Okay. Today we're going to start talking about variables, assignments, and operators. We've already done some of the variable stuff. You've used them in the lab and the assignments. Name, age, those were variables. We talked about problem solving and algorithms last week. We went ahead and introduced Python to you. We introduced some basic programming. So done all that. So now we're going to get into a little more advanced stuff. So we're going to start talking about values and data and what computers are putting in those variables. So variables can hold a lot of different things. They can hold numbers, they can hold a word, they can hold a sentence, they can hold different types of data. Objects are going to be things that we interact with. They're not exactly variables. They're actually things that are built in our programming language that can consist of multiple variables. So like we're modeling something. I can model a student, and that would be an object. The student would have like a name and a grade and a class list. So all those things are held in an object. And when you guys close that door, please. So values have types, right? Python's a very forgiving language in that it doesn't make you set a type when you declare a variable, but other programming languages, you have to know exactly what type of data you're putting in the variable when you create it. So while we don't have to tell Python immediately what the data type is, all data does have a type. So whole numbers are integers, decimal numbers are floats or doubles. Strings are one or more characters. That's a type of data. But strings are also considered objects because they hold more than one thing. And they have functions you can work on them. Strings are going to have quotes around them. So that either single quotes or double quotes around all strings. Technology loves me today, can't you tell? So these examples up here at the top of the slide are all strings. So it's one or more characters. A number can be a character. So like my mailbox number are characters because I can't take the 110 on my mailbox and add it to my neighbor's 184 and get the third mailbox in the string. Because you can't add mailbox numbers together, right? I can't add computer numbers together. So if you're sitting in computer 5 and your neighbor's computer is sitting at computer 6, I can't go 5 plus 6 is 11. So the next one's 8. Because those are identifiers, not necessarily numbers. We're going to do math on, you know. If I need to do math, then I need to declare them. Oops, go back. One of the examples ran off into the picture at the bottom, so I'll fix that later. We need to do them in integers or floating point numbers. Floating point number is a fancy word of saying we're going to have a decimal place. Why they call them floating? Because the decimal place splits up and down depending on what the number is and how many significant digits you have. So integers have no decimal place. They're all whole numbers. Floats have decimal places. Well, if I want to store a number as a whole number into a float, absolutely can. It's just going to have a 0.0 at the end. And it's going to take up more space in memory. Because integers are stored in a smaller amount of space than a float. So the type function is built into Python. So if you have no idea what type a variable is, you can use the type function and put the variable name in there and it'll tell you what it is. The type of this is with a comma in it, 10,000 with a comma in it is going to give you an error because we don't put numbers in with commas with a computer. You would just type the number in and we didn't put quotes around it, right? So if you try these out in idle, you're going to get error messages with these because it's not going to know what to do with them. Does that make sense? So if we type in these, if you want to try them, you can open idle and type them in. But the first one should print out to the screen that this is a string. This one's also a string. Doesn't matter if we use double quotes or single quotes, it's still a string. The type of that should come back as an integer. This one should come back as a float. This one should also come back as a float. Now, sometimes you'll see double instead of float. A double is just got more significant digits. Oddly enough, it has twice as many significant digits as a float. Therefore, it's double in size. Because computer programmers are not necessarily clever when naming things. So we assigned some variables in our last assignments and in our last classes. So this should look pretty familiar. So we can have a variable underscore name because no spaces in variable names is equal to value. First name is equal to Sally. Last name is equal to May. Age is equal to 23. Income is equal to this decimal number. We get down here, we do full name is equal to first name plus a space plus the last name. What that did is it added the two strings in the variable together to make a compound first and last name and put it in a new variable. And then current age can be set to the value inside of age because we set it before we did it. I feel like we did all this last week. Do we have any questions? Am I going? Yes, ma'am. The plus is adding them together.
Oh, okay, so they put them right next to each other.
So yeah, this line right here, if the slide was longer, would be all on one line. So his full name is going to equal to what's in first name plus a space, because if we didn't put that empty space in that string there, it would just run them right up against each other, plus what's ever in last name. So that would give Sally space May as the result of that one. Because we can add strings together, it's called concatenation. And what it does is it goes and grabs the information in the two things that you're adding together and forms a new string. Math expressions work pretty similar. Math expressions work pretty similar to the way you're used to it in math. If you're old like me, the multiplication sign is now a star instead of just an X. So if we can assign variables equal to a math equation, and if we do, it puts the value of the total into that. So if X is equal to 3 plus 5, after we press enter, the value in X is now 8. Does that make sense? X times 2 is going to take 8 times 2 is 16. Y is now equal to 16. Number is equal to pi times 2 divided by 1.5. I can't do that in my head accurately. So it does everything inside the parentheses first, then it does the division. Just like algebra. Hopefully everybody's had algebra. When we get down here, we're dealing with strings. It's going to take goodbye, and it's going to add it to comma space John. So the end result would be goodbye, comma John, right? X is equal to Y, so we had 16 here, so now X is equal to 16. X is equal to 16 divided by 3. Now here's where it got tricky. We had two whole numbers doing division. In computer science, if you have two whole numbers doing math with them, your result is a whole number. So it will throw away the decimal point sometimes if you're not careful. So if you're getting weird math results and you're like, I don't understand why this isn't accurate, go back and make sure that you didn't try to do it with integers and it didn't throw away some of your decimal places. Now, if you have a decimal place in your equation when you start, then you get a decimal place in your answer. Because it makes some assumptions for you. Computer does not always make good assumptions. Right? Still working on that AI thing where it will read your brain, your mind, and do what you want it to do instead of what you told it to do. So if I pulled up idle, and I did some math in here, like the 18 divided by 3, it gave me a decimal place. If you were in Java, it absolutely would not. Absolutely would not. Java would throw it away on it. So be careful, test it. If I have if I do good plus 5, it runs them together, right? If I needed a space between them, I would have to do, I gotta learn to type today. And now I get it with a space in between. So what this is right here is just quotation marks with a space between them. Because if you do that, remember we talked about a little bit last week about how spaces are definitely characters. By doing that, you've added that character into your string and made it more readable when you print it. Does the computer care if you do that? No, it'll just write it all together. It will make it very hard for your users to read it when you print it out, or for you to read it when you need to get more data out of it. All right. So another example, x is equal to 3, x is equal to x plus 2. So it does the math first. So if x is 3, it's going to do 3 plus 2 is 5. Now x is reset to 5. The 3 is gone. X is equal to 5 plus, y is equal to 5 plus 5. So it's 10. So if you set your variable equal to something later down in your code, it overrides the original value. So you can't ever get that 3 back using x because you've overridden it. If you need that piece of data again, you need to create another variable to hold the results of 3 plus 2. There are some extra math operators that you probably haven't used before. Well, you've seen the percent sign, but you've never used it quite this way. It's called modulo. What it does is it returns the remainder of the division. So think back to 3rd grade when you learned how to divide originally, and you had to put the number that divided into it, and then you put the remainder instead of a decimal place. They still teach math that way. I know they're doing new math. Anyway, so what this does is x is equal to 16, and I do 16 modulo 5. It's going to return 1 because 16 divided by 5 is 3, which gives us the 15, with 1 left over. So it's going to do whole number division and tell me what the remainder is. Why do I want to do that? Because it comes in handy when you're doing things like you want to divide things in half, or you want to know if it's even or odd. So if you're doing a lot of math and you want all the odd results to go in one folder and all the even results to go in another folder, you can use the modulo function, because if it equals to 0, it's an even number. It divided evenly into it. If it ends in 1 or any other number, it didn't divide evenly into it. Right? You see this used in things like, or examples would be doing a coin toss. You can make one, or divide it by that. But that's why you do that. So if I had, let's say I have 92 students taking Python this year, and I want to divide them equally into 3s. Can I do that? Well, if I ran my computer program with a modulo and I got anything other than a 0, then I know it's not equally divided by 3. I could do that with really big numbers, or the computer can, and I won't have to do the math, right? I had 904 students, and I know how many groups of 12. I could use a modulo to tell me if it would evenly be divisible by 12. All right, two slashes or 2 division signs means it's going to do only integer division. It's going to throw that decimal point away if you use 2 of them. Remember though, when you get to Java, always going to throw it away if it's integer division. 2 stars is exponential math. So What it means is we're going to do C, in this case, is going to be A, or 2 to the third power. So whatever's after the 2 stars is the power. Why? Because we didn't have a good way of doing superscripts in programming, but we needed a way to do the math. Questions? Yes, sir. This one is a percent sign. So if you see a percent sign at the end of something, then it's probably indicating that it's a percentage. But if it's in the middle of 2 numbers, Python's going to use it as modulo math. That makes sense? So if you try to mix your data types, like you accidentally declared 5 as a string because you put quotes around it somewhere, and then you try to do math with it, you're going to get this red error that says unsupported data types. Now, this is actually going to pop up for you guys more frequently than you would think, because when we start doing programs where you're asking the user for input and you're asking them for a number, all input from the keyboard is read in as a string, and then we have to convert it to a number. And I'll show you guys how to do that as we move forward. But just remember, if you get this error and you've had user input in your program, it probably means you forgot to convert the user input to whatever data type you needed it to be. Because everything read in using the input command comes in as a string. The book has a code lens you can use. You're welcome to use it. It's a great place to teach yourself stuff, try some stuff out, see what happens as you get through it. Not requiring it. It is there for your benefit if you want to use it. You also can do some of it in the shell and test things in the shell to see what the command actually does. Code lens just gives you a little bit more behind the scenes of why it's doing it. So if we all had our idle open, and you can or not, it's up to you. I put a couple of little activities in here that are examples. I'll do a couple of them really quick in class with you. You can go back and do the others if you want to. So this one wants us to write Python code to do the following: create a variable and assign it a value 21, increment the points scored in the variable by 2. So if I go back over to my idle window, and I'm doing this in the shell just because we're testing and we don't need to save it. If I come over here, I can type in points scored. And set it equal to 21. And then I can do points scored. Oops. Equals incrementing it by 2. Increment is a fancy word for I'm going to add to it. Decrement means I'm going to subtract from it. So I'm going to add to, oops, wrong button. Now if I print out points scored, if I can type it, I should have 23, right? All right, so that was a pretty simple example. The next one is create a variable called average and assign an initial value of 0. y'all know how to put initial values in, right? So let's go down to this one. This one lets you practice some math. Can y'all see the screen in the back? Do I need to, okay, let's make the text bigger. I start doing examples of code. If you can't see it, remind me to make the text bigger. So if we do x is equal to 8, y is equal to x plus 2, y is equal to y plus 1. Let's do a print real quick to make sure we understand what it's doing. So before I press enter, what do you think y would be after the first 3 steps? So x is equal to 8, y is going to be equal to x plus 2, and then y is going to be equal to y plus 1. Anybody have a guess what the total would be at this point? What's y going to be after those 3 steps? 11. See if we're right. Hey, we are. Y is equal to 11. That makes sense? If you get down here to this one, x is equal to 2 times y plus, 2 times y plus x. Now I can do x, and we should end up with, who's got morning math going? So if this is 11, this is come on. 30. Okay, so y is 11. So 2 times 11 is 22, plus 8 is 30. Oops. I hit the arrow key if we printed a lot of it. That makes sense? So absolutely that the order of operations you learned in math in school, the PEMDAS thing, parentheses, exponents, multiplication, division, adding, subtraction, absolutely works. The only thing different in this case, or in computer science case, is you have to throw modulo in there, and it comes in with your multiplication and your division. So you're gonna do the modulo before you do the adding and the subtraction. Me personally, I throw parentheses into all of my equations because it visually reminds me what I'm doing, and it just makes it clearer to see. Never hurts to have a couple extra parentheses in there to make sure that the math's going the way you thought it would. All right. That seems to be enough examples for right now. If you got down here to this one, you know, it's going to follow those orders of operations, reading left to right, and then all that. All right. Moving on to functions. So far, what we've been doing is single lines of code. Not very reusable. We're just typing single lines of code. So what we're going to do moving forward, if my computer sticks with me, is we're going to start building units of code that do something that we can reuse. So they're called functions in Python. You'll also hear me interchange the word method because Java calls them methods, and I'm teaching both Python and Java this semester. So I might mix my terminology up a little bit. So we're going to do functions. They perform a action. Functions should be streamlined and simple. They should do one thing and do it well. So if I create a function that's going to give me the area of a square, then all it should do is give me the area of a square. right? It shouldn't also tell me the area of a circle. So it's going to perform an action like print stuff, right? Draw a unit square. It's going to draw the unit square. Draw a circle is going to take information to know how big a circle and what color you want it. So 5 would be the diameter. What color you want it drawn in is in the quotes. They can return information, so they do a calculation like the area of a square. Well, we need that information returned back to the program where we can use it. So it absolutely can create things. Input is a function that we've used that returns a value. It returns whatever is typed on the keyboard. And then that information we assigned to a variable name. Now, it will return the information whether you assign it to a variable or not. It just goes into the ether of your computer and it's gone. If you want to determine a letter grade, you put in a grade, it should give you back an A, B, C, D, or F, right? Oddly enough, these are all functions that you're going to use or build during this class. So if it input always returns a string. The function was designed to give you a string value. If you need it to become a float or a double or an integer, then we have to do something called casting. We cast an actor into a role. We're going to cast a value into a data type. So in this case, if you ask them to input the cost of a purchase and you ask them to input the tax rate, and you try to figure out what the tax would be on that purchase, this is sound logic, except for the fact you can't do math on strings, right? So you get a runtime error telling you that you need to change it. So the way you do that is really simple. You take the data type, in this case, of this example, they're using integers. So you take the data type, and integer is always abbreviated in programming as int or called an int. So you take the data type and you put parentheses around what you're changing. You cannot do this. You cannot do letters or strings of letters into an integer. It has to be characters that are actual numbers. Does that make sense? Because John, the J in John is not a number. No matter how you look at it, you can't make that a number. I can force it all day and you're not going to get a number. You can take float the same way. You put it around numbers. As long as there's not a letter in the data, you're good. So you couldn't do 7x and think you're getting it 7 times the variable x. That's just not the way it works. So if we go back to that other example about cost and tax, what we would do is we would do cost is equal to the input, enter the cost of the product. And then the next line down, we would do cost is equal to float cost, because we stored the data initially in this variable. So we can use the variable here and force it to be a number and put it back in itself. Because Python doesn't force a variable to be a specific type. You just have to change the information. Same for tax rate. You ask for the input. Once you get the input, change it to a float, and then you can do the math on it and get the actual tax you paid on that, or you should pay on that object. This is something that I want you guys to start practicing. And if I helped you with stuff on last week on Friday, or even in the lab, I tried to tell you guys that I really think you should do it this way. Incremented and iterative development. It doesn't matter what order you say those in. What it means is do it in small pieces. Like I gave you assignment 1, and it was broken into steps because I'm trying to get you to do it in small pieces. Now, could you have read the entire assignment sheet, typed all the code, and then tested it for the first time? Yes, but it's not a good practice, because if you do it in small pieces, you get one part working before you move to the next one. When you do run into a logic error or into some sort of runtime error, you know how much of it was already working, and you can zero in on where the problem should be. If you write 100 lines of code before you test, it's a lot harder to figure out where that logic error is than if you wrote 10 lines of code. Yes, sir.
Can you clarify the difference again between a float and a string?
A string is characters of numbers, letters, symbols. You cannot do math on a string. Floats are decimal point or floating point numbers, so it has a decimal place that moves up and down.
Okay.
Is that better? Okay. Testing to verify something works frequently will make your sanity stick with you longer. Will keep you less frustrated. It also will make it easier for me to help you. We also are going to talk about putting in print statements for testing purposes. You may not be ready to see the final result, but you can print what a variable is periodically through there to see if it's getting what you think it should be getting. I know when I first started doing especially recursion and higher level programming things that repeated infinitely on top of themselves, sometimes I had to put a print statement in there to see how far I got before it failed. So diagnostic print statements are absolutely one of my favorite things to test with. I use them all the time. You'll see me do it up here in examples. You'll see me put them in your code just to help me figure out where it's gone. Literally can print things like made it here. Print the tax rate and then have it print out whatever the variable is. You're not going to necessarily turn it in with these lines in there. It's very easy to put the number symbol or the pound sign in front of it and make it a comment. Now it doesn't show up when you run anymore, but it's there to help you and me diagnose problems. Am I going to take off if you forget to go take these out? Probably not. 90% of the time, no. I might give you a little note that says comment your print statements out. But while you're learning, they're great tools, right? Error messages, as you found while we were working on assignment 1, if it's a syntax error and you mistype something, it shows up pretty quickly, almost immediately. If it's a logic error, it's not going to show up until you run it. If it's a runtime error, it also is not going to show up until you run The syntax errors are usually easy to fix. The runtime errors usually a little more cryptic, but they do usually give you a line number. Did everybody figure out how to show line numbers when they're doing code? So if you go in and you create a file, you can go up to options, and there's actually under options, you can show your line numbers. And they'll put a little down the left-hand column, a row of numbers, and the error message line number will match up to one of those numbers. Runtime errors are usually on the line that it says or the line above it. Like if you left off a closing parentheses on the line above it, then sometimes it catches it on the next line. If you can't see anything wrong with the line it gave you, look at the line immediately above it. There is a link built into this PowerPoint that will show you some common errors. It's not working. I will go get it fixed. There is websites that will show you some of the common errors. You can go look them up if you're not in class or you're not near somebody that help you. You can Google search error messages. There's all sorts of Python information out there. The easiest and fastest way is to email me or go to the CSX lab, and they'll be happy to help you. And that is all I have for today. Questions or comments before I turn you guys loose? I'm going to take your silence as you all understood that, and you're going to do super on your lab coming up. So next class period, I'm going to do lab 2 with you in class and get you started. For the first few weeks, we'll be able to get all of the lab done probably together. So if you, easy grade right there. I also will videotape it. So for everybody online, there will be a videotape of the labs being demonstrated. Friday, we'll do assignment 2 in our Friday workshop. You can choose to opt out of that if you've got assignment 2 working on your own, but that's completely up to you. All right, Hal, have a great